Okay, so this one is the second of the two styles we're looking at for log equations. Remember that first kind has logs on both sides, so for that we want to just get it to log equals log, and then we can set the arguments equal and solve. This is the harder kind, so this is the one where we have a number out here. In either case, the first thing you would want to do is try to write this as a single log, so let me do that. So it'll be x minus 4 equals 1. So all of this right here is in the argument of that log. So from here now we have it down to log equals a number. And so if you remember with our basic definition, I always use log base 10 of 100 is 2 because it makes better sense with numbers. But so remember that 10 raised to the second makes 100. 10 to the second makes 100. So what we're doing over here is saying 12 raised to the first equals that stuff inside. So 12 raised to the first equals x times x minus 4. So that let me get out of this log notation and into just, something quadratic that I can solve. So from here we got 12 equals x times x would be x squared, and x times minus 4, so minus 4x. Let's bring this 12 over, and this should factor. It doesn't have to, but these ones aren't designed to be so terrible. So we'd factor this and find our solutions. And we could have no solutions, one solution, or two solutions. And we will just have to see when we get our answers. So this does factor. Multiplies to negative 12, adds to be negative 4, would be negative 6 and positive 2. If I had tried to factor this and it didn't, and I tried to then solve with quadratic and got no real solutions, that would be the case where this wouldn't solve. Here we're going to see a case where one of the solutions works and one doesn't. So our possible answers are x equals 6 and x equals negative 2, but we can't take the log of a negative number. If you remember what a log graph looks like, it's something like that. We can't put negative values of x in here. And with that, I gotta be a little bit careful. If we had, let's say we had log 2 minus x, then if I put that 6 in there, that wouldn't work, and if I put the negative 2 in there, that would. So it's not necessarily that the number can't be negative, it's that when you substitute it back into the original equation, you can't be taking the negative of log, or the log of a negative number. So this negative 2 is out because that makes either of those arguments negative. 6, you can take log of 6. 6 minus 4 is still 2, so that's still big enough. So that one is your one solution. And like I said, it could be that this didn't factor and you had no solutions. One of these could work or they could both work. It's just kind of how the quadratic solves.